Hello everyone, welcome back to the channel. Now we are going to understand disaster recovery in AWS. So first of all, what is disaster recovery? So disaster recovery is basically say some events which occur, right? Say it could be floods, earthquake, uh, anything. It could be some crisis that happens and your system goes down, and then somehow you have to bring up the system. So that is called as disaster recovery. We have to make the system available as soon as possible. So this is bringing up the system in least possible amount of time with least amount of data loss. So that's the whole objective of disaster recovery. Generally, you would have heard the term like BCP, business continuity plan, etc. We have like one primary site and one DR site. So those terms are related to disaster recovery. So just keep that in mind. So this is about the disaster recovery, and in terms of for disaster recovery, you have to always keep these two terms. Uh, you have to understand these two terms, which is RTO and RPO. RTO is basically recovery time objective, the amount of time it takes for the system to come up back again after the disruption. Suppose your system basically goes down at some point in time, say around 10:20, and then the restoration time to bring up the system is like 40 minutes. So it will be up by 11. So that's your RTO, the recovery time. The amount of time it took to bring up the system is a recovery time. And what is a recovery point? When we say recovery point, it is talking about the data loss that can occur. So if your it all depends, it all boils down to the amount of the frequency of your uh, backups basically that you take. The if the frequency of the backups or the application that you do is is at a very lesser interval, say it is 5 minutes, then your RPO would be 5 minutes. Say suppose I back up data every 5 minutes, then obviously my data loss would be only of around 5 minutes, not more than that. And if the data backup interval is huge, say like it is, I just do data backup once in 12 hours, then obviously if system goes down, then that the amount of data loss could the maximum amount of data loss that could occur is around 12 hours. So those kind of scenarios. So it all depends on how what is the capacity of of the application to actually uh, lose the amount of data that it wants. Actually, generally it should be as less as possible, but it also comes down to the cost. So this is about the RPO and the RTO. And so again, just the key takeaway is like RPO focuses on how much data you afford to lose, right? RPO is focusing on the data, okay, and RTO is focusing on the amount of time to bring up the system. So these are the two key terms in terms of disaster recovery. And in AWS, there are multiple AWS disaster recovery strategies. So let's understand them one by one. The first is backup and restore. So this is the cheapest option that you could say in disaster recovery strategy. So you have a primary site which is up and running, and there is a scheduled backup which is taking up, which is happening at regular intervals. And the backup copy is also sent to the DR site. This is the we are just sending the backup. Yeah, the disaster recovery site is not ready. Now suppose your system goes down, okay, basically the side goes down, then what will happen basically, it will have to restore the backup first of all from the backup copies. Once you restore the backup, and then you have to bring up all the servers, databases, etc., whatever is required in in your recovery environment, or basically your environment, and then your application would be up and running on the DR side. So as you can see, uh, to bring up the system, to restore the backup and etc., that will take some amount of time, right? It is not that it will happen in minutes or few 30 minutes or something. It could even goes to days, right? So this is least with the least cost, but with very high risk, and huge amount of data loss also can occur in this. It all depends on the amount of backup that you are taking. So this is the first strategy. Second strategy is pilot light. Pilot light, basically you have a primary site and the DR site. Okay, now in your DR site, what you are doing is you are running some minimal components, say like you are running your servers, or basically it is installed and kept. Your database is also on the standby. Your things are ready, and then you are also doing backup regularly. Now, as soon as the disaster occurs, right? So what will happen? The servers, etc., and whatever databases, they all would be brought up, which is in the stopped state. So this is like the standby state. It is in stopped state. It is not currently running. but then they are ready. The configuration, etc., and everything is ready on the DR side. It is just that once the disaster occurs, then you have to bring up that system, and then you have to point it out to the point the application to the DR side, and then that's it. Then you have to start your running. It is cost effective with minimal standby, as you can see. But then again, the restoration time could go up to hours, few hours. So that is the problem with the pilot light also. Now there is also the third approach which AWS provides, which is your warm standby. Now warm standby is basically your web servers, applications, your some important components are up and running. It is very close to your, I mean, what a primary site looks like. Not exactly, but then it is still up and running. And then as soon as there is a disaster which happens at the primary site, there are health checks and etc. There will be a trigger, and then the DR site would be actually ready and it will start to serve the traffic. Here things are running, but problem is it is at a very low scale. Say I am running my web servers on the primary side, say 10 web servers, right? But on the DR side, it would be like one web server. Then I would scale it up. As soon as there is a disaster recovery, I would scale it up to match the primary side, and all those stuff will take place. And then this is in this case the recovery is very faster because here most of the components are ready. You just need to scale it up, and it is almost running as well. So that is the thing. But obviously there will be some cost associated because there are two sets which are running. You have to pay the cost of all these things which are up and running, right? So so there is a cost, but then your recovery time, right, is very less, and plus the data loss is also very less compared to the other approaches. And then there is hot site approach, which is the multi-site approach. Okay, in this case, there are two active regions. The both primary and DR, both are up and running. Both are synchronized. The replication, etc., is continuously happening. And then say suppose there is a failure in the primary site, your DNS, etc., will detect that failure, and it will redirect the user to the DR site. So that is your hot site approach. Obviously, as you can see, this is running at full scale. It is very, it is the replica, you could say, of primary site. Obviously, the cost which is associated to the primary site, the same cost will be associated to DR site. Now your cost is double. So this is going to be very costly. But then point is near zero time downtime, near zero downtime. So if you want near zero downtime, then obviously you have to go with this active active approach. This is sometimes called as active active approach. Warm standby is called as active passive approach that we have seen. So, so this is active active approach. Both the regions are up and running, and obviously there will be zero data loss. So this is the disaster strategies in AWS, and just we'll do the comparison once. As we can see, backup and restore. Obviously, your RTO, recovery time objective, it will be could be from hours to days. Hours is minimum, right? And days could be like maximum. And then RPO, again, it would be hours to days. Cost is very low, complexity is low. And then in the pilot light, uh, cost would be medium, but your RTO, it could be up to hours. So minutes to hours. So minimal infrastructure is running in DR set. You just scale the resources on demand. And then RPO again would be minutes to hours. So as you go this side, your RTO and RPO will reduce. Here it will increase. And warm standby, uh, the RPO is very low and RTO is again low, and cost is very high because this is very very close to what is running in the primary site. It's just that few things are running in standby mode, and only few things need to be scaled up. That's it. Otherwise, everything is very close to what a active site is actually, or a primary site is there. You are not serving traffic. That's it from the warm standby. In hot site, active active, both the sites are up and running, uh, and then it can both the sites can actually serve traffic. And based on the uh, disaster that happens on the primary side, etc., the DR can take over. If there is a failure in the DR, then primary can take up. So in that way, both the sites are up and ready, and there is almost near zero downtime and near zero data loss in this case. As you can see, the RTO downtime in case of backup and restore is very high. Pilot light little better than backup and restore. Warm standby little better than the pilot light, and hot site is like zero. You could say near zero downtime. So these are the various disaster recovery strategies in AWS. Thank you so much. Have a good day.